All right, welcome everybody. Let's begin. Good afternoon. All right, since things are going to be happening pretty quickly back to back over the next 10 days, I wanted us to take a little bit of a look into the future here. So you've just submitted homework number 5 on MU Online. The next one that you've got is due on Friday of this week. So that's less than a week. You know, ordinarily till now you've had about a week for each assignment. But I carved the next couple of assignments into smaller pieces, just so that you're not trying to swallow the whole steak in one bite, so to speak. So the smaller assignment number 6 is due on Friday. And then on Wednesday, that's a busy day because you've got homework number 7 that you're going to submit before our normal class time. And then inside class at noon on Wednesday the 20th is going to be exam 1. So I'll give you a little bit of information about exam 1 here in just a minute. So any questions about those scheduling items? No? Okay, so we're going to begin talking about Chapter 5 today, and this is where we start to compare alternatives. So far we've just been laying the groundwork with some analytical tools that allowed you to account for the time value of money. But with only a couple of exceptions, you were only limiting your analysis to just a single thing. Now we're going to actually try and find out what's best, because we live in a world of infinite possibilities. You know, all you have to do is use Amazon for 5 minutes and you know that there's 1,000 different options for every kind of product that you're thinking to buy, and it's like a full-time job sorting through all the reviews and figuring out, is it worth an extra $1 for that, you know, slightly improved quality on the laptop sleeve that you're going to buy. So what we're going to do is learn some quantitative methods that allow you to pick the best alternatives. Before we get into that, a little bit more about the exam. It's going to be here in this classroom. You're not going to have any Excel questions on the exam, so you don't need to bring your computer to class this time. For exam 2, though, there most likely will be some Excel-related questions. Now what you will face on the first exam is there's going to be both concept questions and problem solving. Now the way that I do that is I separate the exam into 2 parts. The first part would be like some short answers. Maybe you're drawing a sketch of some sort to illustrate a phenomena or to revisit some concepts I've taught you in the past. So that's, generally speaking, just as a rough approximation, maybe 35% of the points that are available. And then the 65% of the points that remain are problem solving. So that could be the equation method, could be table lookup method, or other things. So it's both conceptual and problem solving. We only have our 50 minutes. This isn't that situation that I had when I was an undergrad where I could just go camp out in the testing center all afternoon if I wanted to. But you can bring candy if that would help you out. I'm going to provide an equation formula table. So you don't need to prepare an equation sheet of your own. All you need to bring on the exam day is a pencil, an eraser, your calculator, and a lot of knowledge. All right? So any questions about the first exam? Yes?
What chapters will it cover?
It's going to cover everything, including this Chapter 5 that we're starting on today. So essentially, it will include all of this week's lectures and the lecture from Monday of next week. Are there other questions? All right. We might talk again about exam 1 in the time before then, but I just wanted to give you this information early so that if you want to begin going back through your in-class exercises or some of the recordings, then it's better to start early rather than late. All right. One last thing I want to talk about before we get into the new material, and that is I'm getting to the point where occasionally I'll receive emails from students on homework questions, and that's good. That's what I want. I want to help you. That's why I'm here, is because I'm eager to see you learn. So it's good if you send me a question, you know, if you're working away, I don't want you just to be stuck wasting time when, if I can just give you one little hint or redirect you in a different path, and then that solves the uncertainty, and now you can make, you know, meaningful progress, then it's a win-win. But it's most helpful if the way that you summarize your question to me is clear and has lots of details. Now, I'm going to show you just like a hypothetical question. And this isn't a real question that I've received from a student, but it is representative of like all of the bad characteristics of sometimes when I get a question via email that's really tough for me to answer. So this is an illustration of one that would be tough for me to answer. All right. Well, obviously, this person texts a lot, right? They're used to text messaging because nothing is capitalized. There's some abbreviations there, misspelling. It's vague. I hate text messages. It's the worst because the sort of thing that you can iron out in about 30 seconds of a phone call would require dozens of text messages back and forth because it's just so unclear. So the first problem here is I don't even know which assignment you're talking about. Now, most probably it's whichever one is due next, but you know there are a handful of students in this class that are working ahead, that are already on the next assignment after, and so my first suggestion is be as specific as possible, and so here's maybe a better question. Why do you think I like the one on the right better? You know who Charlie Kelly is? All right. Yeah. Well, probably somebody in here doesn't know who Charlie Kelly is, but that's not the main reason I like this one on the right better. Why is it better? It's concise. Now, let me tell you where I am when I get questions like this. I might be at the mall. I might be on a trail run. Now, I'm probably, when I get your message, I'm probably not going to be in front of a computer or with my textbook. So if you take a picture of the question and include that in your email, then even if I'm out in the middle of Ona on the top of some trail, I can still reply to you because you've made it clear what you're not sure about and you've given me the question itself. So you take a little picture and include that. Also, it's kind of more expanding on why there could be some ambiguity there. Maybe it's a question of perspective. Obviously, it's correctly capitalized. It's always nice to be addressed at the beginning of a message and have the sender include their name at the end. It's all around better, and I think you see why. But the one thing that maybe you're not in the habit of is taking a picture of the question that you want me to address. And I'm just telling you that what's helpful about that for me is I want to answer you as quickly as possible. This one, I will eventually get back to you, but I'm going to have to try and like put all the pieces together myself and read your mind. Whereas with this, I don't have to read your mind and all the pieces are given to me from the very beginning, so you're going to get a reply a lot more quickly. So the take-home message is, let me help you. I want you to learn this stuff. I think you probably know that by now, that I really want you to learn about engineering economy and all the lessons that come along with it. So give me all the information you can, and then we'll both be better off for it. Any questions about this? I hope this doesn't discourage you from emailing me, because I'm not judging you every time you send a message if it was like correctly formatted. That's not what this is about. All right. So what we're talking about now is decision making. Engineers are always choosing from alternatives, and so we have to develop a machine or a process of a standardized approach to know which one is best. And this diagram comes from the text, and it's meant to kind of illustrate that even something as seemingly vague and ambiguous as the decision-making process can be diagrammed and can be formalized. And so what this is formalizing is how ideas turned into the selection of a project. So what this is showing is that there's just all sorts of information out there. It may be a boss telling you we need a new product line. It could be that you've got this pool of data, previous estimates from projects. There's just, here in the clouds, a lot of information that's feeding into start a new product line. Should the company renovate headquarters? Should the company or a university begin offering a new major? Think about the major you're in. And how did that major come to be on campus here at Marshall? Somebody had to decide, we ought to start offering that academic program at the university, because none of the majors that we've got in engineering were here 12 years ago. They're all relatively new. So we've got all these proposals, and the first step is to sort them by those that are not viable versus those that are viable. And so there's an initial screening. But even among those that are viable, sometimes a choice is mutually exclusive. Mutually exclusive means that only one of the alternatives can be implemented. So for spring break, your mutually exclusive alternatives are stay home, go to Florida, go to Dubai. You can't do all of those things because you can't be in more than one place at a time. I guess you could go to all of them and just spend a little bit of time in each. But mutually exclusive alternatives are those where you can only select one of the options, whereas an independent project is a project where, as long as you have the resources to implement it, you can choose all that are justified. We're going to learn tools to help us analyze both independent and mutually exclusive. And for the short term, we're going to focus only on projects that are called revenue alternatives. Revenue alternatives are those that actually can pay for themselves because they're generating revenue. It's a project that has the potential to be profitable. But believe it or not, there are plenty of projects that are worth doing that aren't profitable. Those are called cost alternatives. So an example of a good cost alternative would be a flood control dam. You know, here in West Virginia, there's a lot of risk from flooding. And so there are small towns all across the state that would be wiped off the map anytime it rains if there weren't flood control structures upstream of those towns. So nobody is paying on a daily basis for those reservoirs. It's not a profitable thing, at least not directly, to build a reservoir. But we still go through a process of weighing the public benefit and all the reduction in damages and say that some of these cost alternatives can be worth approaching. So this is just a diagram that makes the point that you can formalize the decision-making process. We've already talked about the difference between a mutually exclusive alternative and one that is independent. And so that terminology you need to know and understand in case there's any assessment in your short-term future where you'd need to be able to compare and contrast, for example. Anytime you're choosing from among alternatives, the do-nothing alternative is always implied. What that means is you can always assume that not doing any of the options that you've been given is a choice. And we've discussed the difference between revenue-based projects and cost-based projects. So any questions so far? By the way, we aren't going to use computers today, so just to conserve your battery life, maybe you might as well put those into standby. Or if you're working on something else, direct your attention to the lecture. All right, so in present worth analysis, we have to know what the decision criteria is in order to know which alternative to choose. And so the decision criteria is how you pick and why. And the first step in the analysis is to discount the alternatives to the present. That's why it's called present worth analysis. And so the two options are going to have different amounts. Maybe one is more expensive than the other, but maybe it has greater revenue because it was more expensive. Maybe it lasts longer. And that's a big thing, is trying to account for differences in time. So our decision criteria is that if projects are mutually exclusive, meaning you only get to pick one, the one you pick is the one with the largest positive present worth. If the projects are independent, then you'd choose all where the present worth is greater than or equal to 0 when you're discounting at the minimum acceptable rate of return. Why wouldn't you want to accept a project if the PW is less than 0? What does that mean? It means you're losing money. It means there's more cost than revenue. Okay, so that's the criteria. When you answer a question, you know, for example, which alternative should be selected? You don't just say option A. You say option A should be selected because it has a present worth of 15,000, which is at the MAR, which is greater than 0. So you kind of, in your answer, you state what was the criteria that led to the conclusion. That's a habit that's very important, is not only answering which is the right answer, but according to what standard. And so here, the decision criteria, these are the standards that allow you to make the selection. Now here's the thing that's tricky, is sometimes your options will have a different useful life. And so look at A versus B. Option B costs 16,200, and for that we receive revenue of 4,100 over the course of 9 periods, whereas option A only has a duration of 6 periods, though the amount is greater. Now, we know that our strategy is to find the present worth of each, because we're in present worth analysis. That's what we're doing. So that's the orange arrow there just means we want to find out, if you take this annual series back to the present and you combine it with the amount that's already at the present, we're trying to find out what's the sum of the present worths for option B. But the problem is you can't directly compare things that last a different amount of time. You have to have some sort of a tool to make them last the same duration. That's a new rule that I'm telling you. So this is important. If they have a different number of years, you can't directly compare them. You somehow have to correct it so that they have the same number of years. So today I'm going to teach you one method to make it so that they last the same number of years, and then on Wednesday we're going to do 2 more. So the way that we can compare these 2 options, if we have to make them last the same overall time, is to simply repeat them in cycles. And so option A was shorter. So what we do is we buy the thing in year 0, and we let it run its course. We get 6 years of revenue from option A, but then we have to buy it again at year 6. And by buying it again, what that does is it allows us to continue to have uninterrupted service. We buy it at the beginning of that 6th year, and then we get the revenue at the end of that year, so at the beginning of the 7th period. So you can see that there's continued uninterrupted revenue through the entire 18 years. This approach is called least common multiple, LCM. Why do you suppose it's called least common multiple? What does that mean, least common multiple? Do you see a pattern? Yeah, so if you've got 6-year cycles and 9-year cycles, what you do is you keep repeating until they terminate on the same year. So the least common multiple between 9 and 6 is 18. We could have it go more cycles than that, but then that just makes a cash flow diagram that's even longer. So this is the shortest. Now let me ask you this. Why don't we buy the item again in year 18? Because we're stopping the cycle, and if we bought it again in year 18, then that would give us revenue in year 19, 20, and so we don't need to buy it again in the terminal year. So that's one mistake I've seen a lot, is people buy the item in the terminal year when you don't need to. So avoid that mistake. The other mistake I sometimes see is that people buy it in the wrong year. So it's a temptation for some, see here in option A, sometimes they would buy the item in year 7. But that would be a mistake, because if you buy it here at 7, you don't get the revenue until 8. So then that meant you had some year where nothing was happening. So you need to buy it in year 6 to have the item ready for this period. So those are, I think, the 2 tricks. Is trick number 1, don't buy it in the terminal year. And trick number 2, make sure that you're purchasing the item so that you have uninterrupted access to whatever this thing is. It's a piece of equipment, one would presume. Okay, does that make sense to everybody, what we're doing? Why it's called least common multiple? All right, very good. There are some assumptions, though. What we're assuming when we repeat the cash flow diagram is we're assuming that the item can be purchased for the same amount in the future, and we're assuming that we have the same revenue stream in the future that we did originally. So let's revisit that cash flow diagram. Right now, the item costs $11,500. If we just do a strict repeat, what we're saying is we think we can get the item in year 6 for $11,500. Now that may or may not be true. And so we just need to be aware that that's what we're assuming when we just do a copy-paste into the future. You know, there's some things like computer equipment where, you know, if you're buying a router, like a network router that costs $11,500, probably in the future there will be a similar piece of equipment that costs about the same, that does a similar task. So in other words, I bought a laptop when I started college, and the same number of dollars that I spent then, I can buy a laptop now for those same number of dollars. But that's maybe the exception. Lots of other equipment just keeps getting more expensive over time. So we have to be sensitive to this repeatability assumption. And if it's not true, then just make adjustments. You know, ultimately what we're doing is we're discounting all of this to the present. So maybe you could say, I'm going to make this second cycle, it'll cost me $13,000, then here in the third cycle it'll be $15,000. So, you know, if you're actually implementing this in real life, there are ways that you can adjust that repeatability assumption. So if it's not repeatable, then you should make corrections. The other thing is you need to ask, will the revenues in the future be the same? You know, is it realistic to be projecting 18 years into the future? That, you know, is there a risk of uncertainty that 18 years from now maybe people won't be buying what you're making with that equipment? So these are all reality checks that should be gone through before you commit to one option or the other. All right, so here's what I've got for you in today's in-class exercise. The first one is some questions to get you used to the repeatability. Excuse me, no, this isn't yet repeatability. This is just applying the decision criteria. So let me hand these out. Okay, so I tell you on part 1 to just draw each component, not just the net amount when you're doing the sketch of the cash flow, but then on part 2 you can use the net amounts when you're solving. I'm going to give you the 4% and the 10% table. I'll hand those out in just a second here. You got an extra? Oh, thank you. Thank you. Need some over here? All right. How many? 3? Is that 3? Yeah. Okay, and here are the factor tables. I think most of you have better looking cash flow diagrams than me on this one. Here's what the cash flow diagram should look like. So we have an 8-year horizon for each of these alternatives. It makes the analysis a little easier on this problem. We don't have to do anything special. So for each year there's a revenue, maintenance charges, and fuel costs. So show them all. And then in the last year there's just a single salvage value in the future. So then as the solution, what we need to do is find out the present worth of Mitsubishi and compare it to the present worth of Hyundai. So that's here what this one is. There's already some amount in the present. It's the cost is already at the present. But then we need to convert the net revenue for each option to the present because that's an annual series. But then the single amount, that future, that salvage value, you don't use a P/A on that. Since it's a single amount, you do a P/F. So in the end, there will be three components of the present value for each alternative. There will be the initial cost, there will be the net revenue, and then there will be the present value of the salvage. And you can see that I've indicated which option should be selected. But on the second problem, you can see why I don't usually use this pen. That's atrocious. That looks terrible. So if we repeat, we've got to do 3 cycles of option A, 2 cycles of option B. And we don't buy the thing again. But now we have an F here of 11,500 and a different F of 11,500. And this F is 16,200. Okay. How do you clear it? So the method is take all the amounts to the present. The criteria is choose whichever alternative has the highest non-negative present worth. If they both had negative present worths, then our answer would be do nothing. But in this case, they both have positive present worths, and so both options are acceptable. Both of them, when you discount the revenue at the MAR, both options have a present worth greater than 0. So that tells you you'll make a profit. Either option A or option B will be profitable. But option A is more profitable because it has the higher present worth when everything gets discounted to year 0. This can get tricky, but we've got one annual series that goes through the entire 18 years, and then we've got two single future amounts. We've got that future amount in year 6. We've got the same magnitude of the amount, but now we see it again in year 12, so it's not going to be worth quite as much. And you make note of the signs. We're subtracting the initial cost. We're subtracting the next time we buy the items, and then the revenues were positive. So in the end, we've got the initial cost, the present value of the revenue, the present value of the second time we buy the item, and the present value of the third time we buy the item. So we're accounting for everything. Okay, so that intruder tells us our time is up. It's 12:50. I'll see you again on Wednesday. We're going to continue talking about present worth. Please feel free to let me know if you've got any questions, and I will see you then.